All right, section 5.4 is about factoring, and we should have gotten sort of good at factoring, otherwise known as unfoiling, when we did quadratics. There's a few new methods here, so I'm going to break this down to 3 videos. So the first is going to be factoring by the greatest common factor and then using the sum or difference of cubes. So we're going to start with, you should always look for the greatest common factor, right? GCF, greatest common factor. So I want to always try to make it simpler. So everyone here shares an x. So I'm going to pull that x out. It's sort of undistributing. So I have to think about x times x squared would be x cubed. X times 2x would be 2x squared. And x times a negative 15 would be negative 15x. So I've factored out an x. And then this becomes relatively easy to solve then. Remember our trick, when the leading coefficient is 1, what are the factors of 15, negative 15 that add to 2? 5 and 3, right? 5 and 3. And if the 3 is negative and the 5 is positive, I'll get a negative 15 and a positive 2. X squared minus 3x plus 5x would be 2x, plus 5 times negative 3 would be negative 15. So this trinomial factors into 3 factors, an x plus 5, and an x minus 3. Greatest common factor. What do 2 and 18 have in common? They have 2. What do a y to the 5th and a y cubed have in common? The greatest common factor would be a y cubed. So again, what would I need to distribute this to get a 2y to the 5th and 18y cubed? So I still need 2 times 1 would be 2. Y cubed times y squared would be y to the 5th. And then here I'd need a 2 times a 9 to get an 18, and a y cubed gives me a y cubed. Now the trick here is to see, I put that 1 in here, but the trick here is to see I have 2y cubed times y squared minus 9, and to look at that and go, oh yeah, there's that special, there's a difference of perfect squares. So here's a 2y cubed times a y plus a 3 times a y minus 3. So here's your 3 factors for this binomial: 2y cubed, a y plus 3, and a y minus 3. Again, greatest common factor. What do all of these have in common? A 4. What's the greatest factor of those x parts of the monomial? It would be an x squared. So what's all I have left here is an x squared. What do I have left there? A 4x. What do I have left there? A 4. And then again, you'd see that this is an x minus 2 times an x minus 2. And if you really wanted to simplify it, you could call it 4x squared times an x minus 2 squared. I like this, and you'll see why this is nice when we get to finding zeros. But essentially, always take out the greatest common factor first, and then you might have something nice that you can further factor. Not always, but in Algebra 2, they're trying to teach you these things, so they kind of make stuff convenient. So let's see what that means for these few. Oh, and by the way, I'm trying to do problems from the book, so if you want to practice more from the worksheets, I didn't do the evens from the worksheet. So say you just want to do practice A, you have all of those available to you. I didn't take any. So 14x squared minus 21x, I think a 7x is going to be that factor. 2x minus 3. I think that's it, right? 14x squared minus 21x. That's all I can do with that one. How about here? I can factor out a 3y cubed. What's left there? A y squared minus 3 goes into 48, 16. And then what do we have here? A difference of perfect squares. 3y cubed times y plus 4, y minus 4. Again, that idea that there is no middle term. That's a perfect square. That's a perfect square. So my outer term and my inner term must have canceled. That's also the only way you're going to get a minus in there. You have a plus times a minus gives you a minus. 3 factors, 3y cubed, y plus 4, y minus 4. And again, I'm hoping that by the time we've gotten through quadratics, you're pretty comfortable with that stuff. So let's talk about this whole difference or sum of perfect cubes. We saw this a little bit in the pattern. We were looking at patterns of cubes. So this is something I would just like you to try. It's a template. It's good for your brain to plug in. I wouldn't memorize these things. I feel like it's like anything. If you had to use it enough, you would just remember it. I sort of feel like fogging your brain trying to memorize this isn't really the best use of space, but in your brain. But you should have the template available and hopefully be able to use it. So here's an example of a binomial, polynomial, 8x cubed plus 27. What you would need to recognize is that this is a sum of perfect squares. If I take 2 cubes, if I take 2x and cube it, I will get 8x cubed. If I take 3 and cube it, I will get 27. So something cubed plus something cubed factors like this. So this is my A and this is my B. So my A is 2x, so A plus B. 2x plus 3. There's my A plus B. And then I have to take A and square it. And I have to subtract an A times a B, and then I have to square my B. So 2x plus 3, A plus B, A squared, remember I have to square the entire thing, so that becomes a 4x squared minus a 6x plus a 9. Just a template and plugging things in that I know. Here's an A cubed minus a B cubed. 64x cubed minus 1. What's being cubed to get 64? So this is a 4x cubed minus a 1 cubed. So there's your A and there's your B. So when I plug it into the template, my A is 4x, my B is 1. And then I have to square my A, so I've got to square 4x, notice how I put it in parentheses, plus my A times my B. And notice it's a positive 1, because in the formula this is an A cubed minus a B cubed. So my B is a positive 1. And then plus my B squared. So my factors are 4x minus 1, and again, 16x squared, be very intentional about that, plus 4x plus 1. So this difference of perfect cubes factors to this binomial times that trinomial. Fun stuff. Good brain candy. So here's a few examples of that. Here's a sum of perfect cubes. I should have these written up here. An A cubed plus a B cubed is A plus B, A squared minus AB plus B squared, and an A cubed minus a B cubed. So A cubed plus B cubed, that's an X cubed plus a 2 cubed. So X plus 2 times X squared minus AB minus 2x plus b squared plus 4. Here's a difference. So I have y cubed minus 4 cubed. So that's going to be a y minus 4, a minus a b, times an a squared, y squared, plus a times b, plus 4 times y, plus b squared, plus 16. My a is y, and my b is a positive 4, because the formula is negative 4. 27a cubed, recognize that that's a 3a cubed minus a 10 cubed. So there's your a and there's your b. So things become a little more complicated. It's a minus b, so it's 3a minus 10 times a squared plus a times b plus b squared. That's the formula. So 3a minus 10, square that entire thing. And then what happens? Look at this one. Is that a perfect cube? No, it's 3 times 1, but it's nothing. It's not something times itself, times itself, times itself. So I'm going to think, oh, I must be able to factor a 3 out here. So 3 goes into 192. 3 goes into 1864 times. That's looking a lot better because now 64, that's a cubed. So this is actually a 3 times a 4w cubed minus a 1 cubed. And then you could just plug that whole thing into the pattern. I'm going to start up here. So the 3 still stays. Then I have my a minus b. So my 4w minus b. Then my a squared, 4w squared, plus my ab, plus my b squared. So there's my 3 still out front. There's my a minus my b, a squared plus ab plus b squared. Shoo. Fun with that. This is all very good. Well, I'm getting kind of messy. This is all good algebra skills. As I say, calculus isn't hard. It's all the algebra you end up with. All right, so that's video 1. Next, we're going to do factor by grouping and quadratic form. Next video.